Hello everyone, welcome to this episode of Winbond Talk. I'm today's host, Wei Shan. Very glad to meet you. First, it said that AI combined with IoT technology has greatly elevated the progress of AIoT. In order to cope with more powerful edge computing and AI, low power consumption and high bandwidth memory are indispensable. In the face of this scenario, how can we address the challenge? Today, we specially invited Jackie from Winbond DRAM Product Marketing Department. Welcome, Jackie.
Hello everyone, this is Jackie from Winbond DRAM Marketing Manager and AI-related market development. Today I would like to introduce the GP Booster DRAM. It means the low power consumption and high bandwidth.
Alright, DRAM can be broadly applied, so everyone must be very curious about how Winbond deals with such cases. Have you developed some solutions for the industry?
Okay, from this slide, you can realize Winbond has worked on those applications. We start from hyper-rare low power R1, low power R2 to low power R3 and low power DDR4. Those kind of correspond layout and comprehensive. Of course, for each bandwidth, we have adopted the highest amount of input. For example, for low power DDR4, it can hit 4.2 Gbps. For low power R3, it can hit 2.13 Gbps. For corresponding applications that range from AI, voice, image, and super resolution, all can hit high bandwidth to run. If we look into resolution from Full HD, 2K, 4K, even 8K, high bandwidth is also must. No doubt, a high bandwidth memory is also must to support the operation.
So we just mentioned AIoT, higher computing capability and bandwidth are suggested to implement AI, but many products may not necessarily be mounted with such a high density of DRAM. In this case, will Winbond also adjust their product lines?
That's right. Let's see the next slide. This is what we said about the GP Booster DRAM. It means the green power booster. It features low power consumption and the power saving mode. With the high bandwidth memory, many people think that general low power DRAM, but the point is not only low power consumption but also high bandwidth to echo different scenarios. So Winbond launched a product line to include such special application. In this chart, we can see from the vertical axis, the power goes from 0.05 watt to no more than 0.4 watt. That means Winbond's GP Booster DRAM represents a considerable achievement in low power consumption. As for bandwidth, we can tell from the axis, it goes from 2.13 GB per second up to 17.02 GB per second. This is the workable scope we can manage. If now we apply this graphic to 4 applications, Hyper-RAM is probably at the lowest end of AIoT application, such as handset, TWS or equivalent. Next one, we recently worked with the very famous AI company named DRAM. DRAM used 512 megabit low power DDR2, and next one is KL720 used 1 gigabit low power DDR3. For the smart camera, we consider for low power DDR4 with the high bandwidth. From this chart, we can say that GP Booster covers all range of AIoT scenarios that we can support. If faced with such similar requests from customer, Winbond indeed can operate it on such a product line.
You just mentioned GP Boost DRAM. I believe the audience is very eager to know more details. Can you share your ideas with us?
No problem. GP Booster DRAM with low power consumption feature. We actually design every product differently. Hyper-RAM has a special feature, hybrid sleep mode. When entering this mode, the power can be under 100 microwatt. For low power R2 and the low power R3, we have also come up with the unique design for standby mode. This we have rarely gained the upper hand on low power consumption. As for boost, just like the general low power 3, normally is the 1.8 Gbps, but we can reach 2.13 Gbps per I/O. What's better is the total bandwidth can reach 8.52 GB per second. This is the reason why DRAM is willing to be partnered with the Winbond.
That's right. Nothing can beat Winbond. So the strategy for low power consumption and high bandwidth products is very complete. Thanks for your sharing, and thank you all for watching today's Winbond Talk. I'm Wei Shan. See you next time.